Welcome to all. I am Captain Dr. M. Tamil Selvi, Associate Professor and Head, PG and Research Department of Mathematics, Seethalakshmi Ramaswamy College, Trichy. The video consists of Mother of all sciences, mathematics. There is no world without numbers. Maths in biotechnology. Mathematical areas like calculus, probability theory, linear algebra, abstract algebra, graph theory, algebraic geometry, topology, dynamic systems, equations, and coding theory are applied in biotechnology. Maths in astronomy. Astronomers use maths all the time. It is used to perform calculations when we look at the objects in the sky with a telescope. Astronomers use maths when they are forming theorems for the physical laws that govern the objects in the sky. Some interesting facts. The remaining lifetime of the sun is 4.76 into 10 power 9 years. Our galaxy Milky Way is about 100 into 10 power 3 light years wide. Moon is about 50 million kilometers from the sun. The diameter of our planet Earth is 12742 kilometers. Temperature of the core of the Earth is 6000 degrees C. Do you know the temperature of Earth core is as hot as sun? Maths in mechanics. Mechanical engineers use maths with the analytical and problem-solving abilities to develop or repair new machines. Basic maths, calculus, and trigonometry are important maths skills required for a mechanical engineer. The general study of the relationship between motion, forces, and energy is called mechanics. Examples of application of maths in mechanics. Speed is measured as distance traveled per time taken. Force exerted is equal to mass into acceleration. Gravity of the Earth is 9.8 meters per second. Maths in chemistry. Mathematics is used widely in chemistry as well as all other sciences. Mathematical calculations are absolutely necessary to explore important concepts in chemistry. Without some basic mathematics skills, these calculations and therefore chemistry itself will be extremely difficult. Scientists put only the digits they can reasonably be certain in their numbers. They might say, for example, that they measured 10 cm. Note the decimal point. Max in medicine. The human body is the entire structure of a human being, comprises head, neck, trunk, arms, hands, legs, and feet. Every part of the body is composed of various types of cells. In our body, there are 206 bones. The temperature of the normal human the blood pressure of our body is 80. Our brain uses 20% of the total of the blood in our body. Maths in physics. Physics is probably the one area of science where many aspects of maths has been directly applied. Some of the important physics are classical mechanics, electromagnetism, general relativity, quantum field theory, superstring theory. Maths in everyday life. We apply mathematics in simple activities that we do every day. Our mother uses the concept of ratios and proportion during cooking. Ratio is used to compare quantities. Proportion is used along with the ratio when the quantity of ingredients increases. The main topic, the K-super harmonic mean labeling of certain snake graphs. Introduction. A graph labeling is an assignment of integers to the vertices or edges or both subject to certain conditions. Somasundaram and Pondraj have introduced the notion of mean labeling of graphs, R. Kondraj and D. Ramya introduced super mean labeling of graphs. S. Somasundaram and S. S. Sandhya introduced the concept of harmonic mean labeling. S. Sandhya and C. David Raj introduced super harmonic labeling. We extend this notion to K super harmonic mean labeling. In this paper, we investigate K super harmonic mean labeling of some snake related graphs. Definition. Let G be a PQ graph. P represents number of vertices, Q represents number of edges. And F is a mapping from V of G to 1, 2, 3, etc. P plus Q be an injection. For each edge E equal to UV, let F star of E induced edge labeling equal to upper of 2 F of U F of V by F of U plus F of E, or lower ceiling of 2 into F of U F of E by F of U plus F of E, then F is called super harmonic mean labeling. If F of V equal to F star of E, E belongs to edge set of G equal to 1 to etc. P plus Q. A graph that admits a super harmonic mean labeling is called super harmonic mean graph. Definition. Let G be a PQ graph. F is a mapping from vertex set of G to K, K plus 1, K plus 2, etc. P plus Q plus K minus 1 be an injection. For each edge E equal to UV, let F star of E is equal to upper ceiling 2 into F of U F of E by F of U plus F of E, or lower ceiling 2 into F of U F of E by F of U plus F of E. Then F is called K super harmonic mean labeling if F of E union F star of E equal to K, K plus 1, etc. P plus Q plus K minus 1, where K is an integer. A graph that harmonic mean labeling is called K super harmonic mean graph. A triangular snake Tn is obtained from a path u1, u2, etc. un by joining ui and ui plus 1 to a new vertex vi for I less than or equal to 1 less than or equal to I less than or equal to n minus 1. Next definition. An alternative triangular snake A of Tn is obtained from the path u1, u2, etc. un by joining ui and ui plus 1 to a new vertex vi. A correlated snake q1 is obtained from the path u1, u2, etc. un by joining ui and ui plus 1 to new vertices vi and wi for 1 less than or equal to I less than or equal to n minus 1 respectively, and then joining vi and wi. An alternate quadrilateral snack A of Q1 is obtained from a path U1, U2, etc. Un by joining Ui and Ui plus 1 alternative to a new vertex Wi respectively, then joining Va and Wi. Theorem. A triangular snake Tn n greater than or equal to 2 is K super harmonic mean graph for all K greater than or equal to 2. Let V of Tn is equal to Ui, 1 less than or equal to I less than or equal to n, Vi 1 less than or equal to I less than or equal to n minus 1. Then E of Tn is equal to set of all Ui, Ui plus 1, 1 less than or equal to I less than or equal to n minus 1, Ui Vi 1 less than or equal to I less than or equal to n minus 1, Ui plus 1 Vi 1 less than or equal to I less than or equal to n minus 1 be denoted as in the following figure. First, we label the vertices as follows. Define the function f v of Tn to k plus 1, k plus 2, etc. K plus p plus q minus 1 by f of u1 is equal to k plus 3, f of ui is equal to k plus 5i minus 5, for 2 less than or equal to I less than or equal to n. F of V1 is equal to K and the other F of Vi is equal to K plus 5i minus 2 for 2 less than or equal to I less than or equal to n minus 1. Then the induced edge labels are F star of U1, U2 is equal to K plus 4. F star of Ui plus 1 is equal to K plus 5i minus 3 for 2 less than or equal to I less than or equal to n minus 1. F star of Ui Vi is equal to K plus 5i minus 4 for 1 less than or equal to I less than or equal to n minus 1. F star of V1 U2 is equal to K plus 2. F star of Vi Ui plus 1 is equal to K plus 5i minus 1 for 2 less than or equal to I less than or equal to n. Thus, f of V union f star of E equal to k comma k plus 1 etc. k plus p plus q minus 1. Therefore, Tn is a k super harmonic mean graph for all k greater than or equal to 2. This is an example for k is equal to 900 and n is equal to 8. Next theorem. An alternative triangular snake A of Tn is a k super harmonic mean graph for all k greater than or equal to if the triangle starts from the vertex to A of Tn. Consider the path u1, u2, etc. un. To construct alternative triangular snake, join ua and ui plus 1 alternatively with the new vertex vi. The ordinary labeling is given below. Assume that n is even. The function f is v of a of tn is k, k plus 1, etc. k plus p plus q minus 1 by f of u1. The first vertex is labeled by f of u1 is equal to k plus 3. The other vertices are f of u 2i minus 1 is equal to k plus 7 into I minus 1 for 2 less than or equal to I less than or equal to n by 2. F of u 2i is equal to for even numbers equal to k plus 7i minus 2 for 1 less than or equal to I less than or equal to n by 2. And the new vertex f of v1 is k and for the other I varies from 2 to n by 2. F of vi is labeled as k plus 7i minus 4. Hence, the induced edge labels are f star of u1, u2 is equal to k plus 4. F star of u2i plus 1 is equal to k plus 7i minus 1 for 1 less than or equal to I less than or equal to n by 2 minus 1. F star of u2i minus 1 u2i is equal to k plus 7i minus 5 for 2 less than or equal to I less than or equal to n by 2. F star of u2i minus 1 vi is equal to k plus 7i minus 6 for 1 less than or equal to I less than or equal to n by 2. F star of u2 v1 is equal to k plus 2. F star of u2i vi is equal to k plus 7i minus 3 for 2 less than or equal to I less than or equal to n by 2. Define for assume that now n is odd. Assume that now n is odd. Define the function f v of a of tn k plus 1 etc. k plus p plus q minus 1 by f of v1 is equal to k plus 3. For I varies from 2 to n plus 1 by 2, we define f of 2i minus 1 is equal to k plus 7 into I minus 1. F of u 2i is equal to k plus 7i minus 2 for 1 less than or equal to I less than or equal to n minus 1 by 2. F of v1 is equal to k for I less than I for I varies from 2 to n minus 1 by 2. F of vi is defined as k plus 7i minus 4. The induced edge labels are f star of u1 u2 is equal to k plus 4. F star of u2i plus 1 is equal to k plus 7i minus 1 for I varies from 1 to n minus 1 by 2. Then f star of u2i minus 1 u2i is equal to k plus 7i minus 5 for 2 less than or equal to I less than or equal to n minus 1 by 2. F star of u2i minus 1 vi is equal to k plus 7i minus 6 for 1 less than or equal to I less than or equal to n minus 1 by 2. F star of u2 v1 is equal to k plus 2. F star of u2i vi is equal to k plus 7i minus 3 for 2 less than or equal to I less than or equal to n minus 1 by 2. Therefore, f of v union f star of e equal to k comma k plus 1, comma k plus 2, etc. K plus p plus q minus 1. The condition is satisfied. Therefore, we say that A of Tn is a k super harmonic mean graph for all k greater than or equal to 2. The following is the example for k is equal to 800. It is true for any number. Next theorem, an alternate triangular snake is a k super harmonic mean graph for all k greater than or equal to 1 if the triangle starts from the second vertex of A of Tn. This is ordinary labeling. The first one is given by the vertex labeling, then the edge indivisible are given below. For n is odd, similar way we define vertex labeling and induced edge labels. This is an example for k equal to 100 and n is equal to 9. Next to the quadrilateral snake, Q1 is a k super harmonic mean graph for all k greater than or equal to 2. This is a general diagram for quadrilateral snake graph. The vertex labeling defined in the following fashion, and the induced edge labels are given in f star of u1, u2 is equal to k plus 6. For the other, I varies from 2 to n minus 1. F star of ui, ui plus 1 is equal to k plus 7i minus 4, etc. Example, for k is equal to 200, it is given below. Next theorem, the alternative quadratic snake A of Q1 is a k super harmonic mean graph for all k greater than or equal to 2 if the coordinate starts from the first vertex of A of Q1. The ordinary labeling is given in the figure. The vertex labeling and the induced edge labeling are defined in the pattern. When n is odd, it is differently defined. And edge labels are induced edge labels are given below. Example for k equal to 600 in the following figure. An alternative quadrilateral snake A of Q1 is a k super harmonic mean graph for all k not equal to 2. If the quadrilateral starts from the second vertex of A of Q1, the ordinary labeling is given below. And the vertex labeling and induced edge labeling are well defined for odd and even. Next example, it's it's k equal to 500 is defined. Okay. Thank you.